These notes will all be about SI units, the International System of Units. Some will be fairly obvious and some are less common than what we will be using in the chemistry classroom. We'll start with volume here at the top. For volume, this is one that's a little strange. There is officially no SI unit. It is cubic meters, which is obviously derived from length. So it is commonly used in chemistry that we are measuring things in liters, but officially that is not the SI unit for volume, but it is the one that we will most often be using. So if we look here, as we're kind of writing our notes, volume SI unit is cubic meters, but there is no official unit. ML or L are commonly used for us, and the non-metric SI unit is going to be the liter. In terms of just conceptualizing what liters are, since in America we use the English system, so we're thinking more of like quarts, cups, pints, gallons. A drop of water tends to be about 1 milliliter. A teaspoon of water is about 5 milliliters. If you're drinking a juice box, that's probably 200 milliliters. A pop can or a soda can is going to be about 350 milliliters. A gallon of milk is about 3.75 liters. So 1 gallon is almost 4 liters, not quite. And then a cubic meter is going to be 1 kiloliter. So if you're thinking of a gallon, a fourth of a gallon is about a liter. Obviously, 2-liter pop is 2 liters, 1 liter pop, 1 liter. So you do have a little bit of metric bleeding into everyday lives that help you kind of conceptualize a little bit more. The next one I'm going to talk about is going to be moles. Moles is a unit that we're going to see a lot next semester. This is a counting number, like a dozen. So when we start talking about how many atoms are in a sample, or how many particles or molecules are in a sample, it's going to be helpful to us to use this number of mole, because the things we're going to be counting are going to be so tiny that it is going to be too hard to really think about the number. And so instead of saying there's 1.2 times 10 to the 25th of something, we would just say there's like 3 moles of it. Temperature is going to be something we use in chemistry as well. We do not use Fahrenheit ever in science. We have 2 temperature scales that will be used. The first is Celsius. This is a relative scale. So the way that Celsius was kind of designed is they took water, they said it freezes, we'll call that 0. It boils, we'll call that 100. And everything else relates to that scale from water. However, this is not really based on any property of particles themselves. And so that leads to some issues, because obviously water is not the coldest thing that can possibly exist. And so we end up having negative temperatures, which for our day-to-day purposes, not a huge deal. But in science, we can't have temperature be negative, because when we do calculations, all of a sudden we're getting negative mass or negative volume, which are not possible. So we needed a temperature scale that started at 0 and only went up. And that's where Kelvin comes into play. Kelvin and Celsius are related by this equation here. Kelvin equals degrees Celsius plus 273. So negative 273 Celsius is the coldest temperature possible. And that would be known as absolute 0. And that would be where particles have no motion, no vibrational motion. They are completely stopped. Every other temperature is going to be based on how much kinetic energy or how much movement the particles have on the microscopic level. And so now with that scale, we're based on something that is actually a property of the particle and also doesn't have negative values. Okay, going to our next information here, we have mass. The SI unit for mass is kilograms. Now in chemistry, we're really not dealing with things that large. Kilograms make sense for physics, but for us, we're using the base unit of grams way more. And that is going to just be based on how much matter is in an object. So if I want to, again, think of kind of some common things here to get acquainted with what is a gram, what is a kilogram. A paper clip is about 1 gram. So if you're holding a paper clip in your hand, it's about 1 gram. The mass of 1 liter of water is about a kilogram. If you have a 24-pound bag of dog food, that's going to be about 10 kilograms. We'll find that kilogram and pound are about half or double comparative to each other. A bubble is going to be about 1 milligram. An average adult is going to be somewhere between 55 and 80 kilograms. If you, for a rough estimate, if you take about half your weight in pounds, that's what you would be in kilograms. A brand new dollar bill, that's also about a gram. Last SI unit to cover here is distance. Distance is going to be the SI unit of meter, which is also the base unit. We in chemistry are not often measuring things that large. We tend to measure things more like in centimeters, especially when we're talking about volume. Some common things here, the diameter of a AAA battery is about 1 centimeter. If you are in the width of a doorway, that's going to be about 1 meter. Sheet of paper is going to be about 21.5 centimeters. Thickness of a dime is about 1 millimeter. A 10-minute walk, if you're walking for about 10 minutes, depending on your pace, you probably walked 1 kilometer. And then from this chemistry classroom that we're in right now to the Mariano's kind of across the street, that is about 1 kilometer away. So that would take you about 10 minutes to walk there from this classroom. And those are all of our SI units that you are responsible for knowing.